Hi, this is 4.2, Evaluating Roots. I'm sorry I didn't have an electronic copy of this ready to go, so I just put the examples on the board in handwriting. I'm sure you guys will be able to follow it just fine. So this is just a little bit of review from Algebra 1, and then kicking it up just a notch, because that's what we do in Algebra 2, is just take it to the next level. So number 1 is kind of a review of square roots. So if we take a look at 1a, we have the square root of x to the 10th y squared. And if you had me in previous years, you would remember the perfect squares and I don't cares. But in this case, because x to the 10th and y to the 2nd are perfect squares, because they're even exponents, remember there's a little 2 hiding here, and as long as it's divisible by that 2, we know that it's a perfect square. So this is simply going to equal the square root of x to the 5th divided by the 2, and then y to the 1st. But if we take a look at b, this is what I'm talking about. Because 8 is not a perfect square, I break it up into what I call perfect squares, and what's ever left over is the I don't cares. So we look at 8 first, and we find out what perfect square goes into 8. Remember, it's got to be the largest perfect square. In this case, it's pretty easy to understand. It's 4, but then 4 times 2 is 8, and the 2 is left over. And remember, this is square root, so we're going to take out an even, anything divisible by 2, and then what's ever left over goes over here, because 8x to the 8th times x is x to the 9th. So now we simplify. We basically take this part and we take the square root of it. The square root of 4 is 2. The square root of 8x to the 8th is x to the 4th, square root of 2x. Remember, at this point, you might want to just pause, write things down, make sense of things. Now, C looks a little more complicated. All right, so here we have a 3x squared y on the outside of our radical, but we're going to do the same thing. We're going to break this up because 98 is not a perfect square, nor is x to the 5th, so we know we're going to have things left over. So then looking at what 98 could possibly be, sometimes just taking your calculator and dividing it by 2, by 3, not by 4 because it's a perfect square, but 5, 7, things like that, you come up with 98 is 49 times 2. So I know 49 is a perfect square, and I know 2 is left over then. And then again, because we're talking about a square root, we're going to take out x to the 4th, and we can take out the whole y to the 8th. But then we have 1x left over. So now make sure you simplify. Remember, this part is the part we need to simplify. This becomes 3xy times 7x squared y to the 4th. But then we still have that square root of 2x. Or we'd like to refer to it as radical 2x or rad 2x. All right, so now you multiply 3 times 7. This is our real portion right here. All right. This is our real part. This is our this is our rational part. This is our irrational part. So we know, I'm just going to write that. This is rational, and this is the irrational portion. So once we simplify this, this becomes 21 x to the 4th, y to the 5th, add exponent, there's a 1 hiding here, square root of 2x. Okay, so let's move on. Taking a look at number 2, being a little bit more complicated here, we're just going to do the same thing step by step and then simplify last. So that's square root of 50. We're going to do the same thing. I know these get a little tedious, but 50 is going to be pretty easy to figure this one out. 25 times 2, take out the x squared and you have an x left over. So this becomes 5 is our rational portion, 5x radical 2x. Now we have another part here, plus x, perfect square, I don't care. 128, when you think about 128 divided by 2, that is 64. So 64 times 2, and we have an x left over here. So let's simplify this again. Now, so this becomes x times 8, so this becomes plus 8x, I'm going to put the variable in the back, radical 2x. Now, because you need two criteria here. First of all, the radicals have to be the same in order to add them. And in this case, the rational portions need to be the same as well if you want to put them together. So in this case, that is possible because the 5x and the 8x are like terms, and the square root of 2x and radical 2x are the same term as well. So 8 plus 5 is going to equal 13x rad 2x. Now, skipping down to D, you should have this worksheet. If I didn't give it to you, I will give it to you the next time we see each other in class. But you're going to do the same steps here. Don't forget about that y on the outside, but perfect square, I don't care, because 32 is not a perfect square. So 32 is going to be, 32 divided by 2 is 16. That's a perfect square. 16 times 2. And then we have x to the third. So that means I'm going to have x squared here, but another x left over that has to go under the radical. And then y to the ninth is going to be y to the eighth, even exponent, but I'm going to have a y left over. So before we move on to the next one, let's simplify this a little bit. Let's do our rational portion here. This becomes y times 4x y to the fourth, which comes out to 4x y to the fifth radical 2xy. Don't forget the radical 2xy. Phew! Okay, let's move on. Now it's minus 7x square root. So the only thing that we have that's a perfect square here is that y to the 10th. And then the 2xy would be left over underneath the radical. So again, let's do some simplifying. Minus 7x times y to the fifth radical 2xy. So that was a little bit easier than the first one. So again, notice how my rational portions both have xy's in them, and my irrational portions have root or radical 2xy and radical 2xy. So what's 4 take away 7? It's negative 3. xy to the fifth rad 2xy. This might be a good time to pause and write things down to make sure you understand what's going on. All right, here's number 3. This gets a little bit more complicated now. Now, the beautiful thing about these, because we have numbers, this can all be done in your calculator. So if they're asking for the fourth root of 2401, you can simply put it into your calculator and do the fourth root of 2401. What you're looking for is what number to the fourth power is 2401. So if you don't have a calculator that's capable of doing a fourth root, you can simply just keep trying numbers. And once you get to it, you get 7. Because 7 times 7 times 7 times 7 turns out to be 2401. But be careful, your calculator will always give you, and I don't want to use x. Let's just not use x. I was just trying to explain something. But the answer to this is going to be a positive and negative 7. Because if you multiply positive 7 4 times, you're going to get 2401. But if you multiply negative 7 4 times, you still get a positive 2401. All right, so let's move on to the cube root. Whoop, that's my cue. I better finish things up here. So the cube root of 1,000, well, I think you're pretty sure that it's some power of 10. So the first time I looked at it, I'm like, oh, 1,000. I mean, 100. No, 100 gives you way too much. But 10, because 10 times 10 times 10 is 1,000. But because this is an odd number, it has to be positive 10. It cannot be a negative. And this is the few times now under the radical, you can have a negative number if it's an odd root. So if it's a cube root or a fifth root or a seventh root, you could have an odd number under the radical. You won't get that way with anything with an even root. So 629, the same thing. This is going to give me a positive or a negative. And then if you think about this a little bit, it turns out to be 3. All right, I think you can try number 4 on your own. tomorrow or in class. And let's move on to number 5, which is definitely the most difficult problems of this paper. So I'm doing 3 of them for you, and you have only 5 to do on your own. But sometimes the easiest thing to do here, when you're looking at cube roots and fourth roots, if you look, there is a fourth root on here somewhere. There they are. Down here on G and H, we have fourth roots. So let's look at how we do a third root, and I bet you can figure out the fourth roots on your own. So when I do perfect squares, so if I'm talking about perfect squares when we do it, the first thing I write down are my perfect squares. My perfect squares are, well, 1 is kind of trivial. Why don't we not talk about that? Why don't we talk about 2? So 2 is 4, 3 is 9, 4 is 16, 5 is 25, 6 is 36, and so on. And we can think about that same thing now with perfect cubes. And this is really helpful to write these down, because the perfect cube for 2 is 8. 2 times 2 is 4 times 2 is 8. The perfect cube for 3 is 27. For 4 is 64. For 5 is 125. For 6 is 216. And for 7 is 343. We might need more than that, but I think that gives us a really good starting point. Because when we start pulling these, the same situation is going to occur. We're going to have a perfect cube, and I haven't come up with a rhyme for what's left over. But our rational portion on the left, our irrational portion on the right. Now, if I take a look here, 16 falls between the perfect cube 2 and 3. So I know it's going to be 8. That's my perfect cube. And what's left over is 2, because 8 times 2 is 16. And very similarly with that square root, we're going to look for numbers that are divisible by 3. So what's the smallest x we can take out? I'm sorry, the largest x we can take out, that's divisible by 3. Well, we can take out 6 of them, but that means that we have 2 of them left over. Right? So now let's rationalize our rational portion. The cube root of 8x to the third is going to be 2. Now the same thing, we're going to divide that 6 by 3 and get squared. And now this is going to be cube root, remember to keep that little 3 in there, of 2x squared. So that's the answer to this one. I know they're a little complicated. We've been working in square roots for so long that sometimes working in a different root makes it a little bit more difficult, but you'll do it. You did it with so many other things, and you'll do it with this too. So let's take a look at B. The same situation. I'm going to have the perfect cube part, and then what's ever left over. So my rational portion is on the left, my irrational portion is on the right. So 108. I know that 108 sits right about here. So I start looking at it. How about 108 divided by 64? 108 divided by 27, and 27 works, because 27 is a perfect cube, and 27 times 4. Now remember, 4 is not a perfect cube, perfect square, but not a perfect cube. And now we're going to take out x to the third power and y to the ninth power, because they're the largest multiples of 3. And then what's left over? I have 2 x's left over and 1 y left over. You can put the 1 if you want to. You don't need to. So let's rationalize our rational portion. The cube root of 27 is 3. X, remember 3 divided by 3 is 1. You can put the 1 in if you want to. Y, 9 divided by 3 is 3. Keep your cube root. 4x squared y. These are not hard. It just takes getting used to. Okay, moving on to our last one before you guys are going to be doing this on your own. Same situation. Because we know 64 is not a perfect cube. 64 is a perfect cube, isn't it? But we still have some other things in here that are not perfect cubes. So we're going to come up with a rational and an irrational. So 64 is a perfect cube. So 64, nothing left over. Now pull out x to the 12th, perfect, divisible by 3. And now we have y to the 14th, but we can only take out 12 of them. So the only thing we have left over in this whole problem is 2 little old y's. So let's rationalize our left side. The cube root of 64, we said, is 4. X, 12 divided by 3 is 4. Y to the 4th cube root of y squared. Probably shouldn't have made that quite so long. Same thing with here. And there's our answer. All right. So you're just going to be finishing these up. Hopefully I've made it clear enough for you. And make good choices. We're done for today. I'll see you again next time. Bye.